Welcome to the Wow Info YouTube channel, your go-to place for fascinating facts and intriguing insights. Today we're here to explore a question that has surely crossed your mind during a flight through a stormy sky. What happens when lightning strikes an airplane? Is it a disaster waiting to happen or just a flash in the plane? Buckle up as we take off on this electrifying journey to unravel the raw power of a lightning strike, understand the science behind it, and see its impact on an airplane. We'll also explore the aftermath of a lightning strike and how modern aviation technology is designed to handle these intense encounters. So sit back, relax, and join us as we illuminate this electrifying topic. Stay tuned. Now that we've set the stage for our electrifying exploration, let's take a moment to visualize this incredible phenomenon. Imagine a stormy sky, a canvas painted with dark, ominous clouds. Suddenly, a brilliant flash of light streaks across the sky, followed by a thunderous roar. This is a lightning strike in all its raw, untamed power. But what happens when this force of nature meets an airplane cruising through the storm? To help you better understand, let's use a simple animation. Picture an airplane, a metallic bird soaring high above the ground. Suddenly, a lightning bolt streaks towards it, a dazzling spear of pure energy. As it strikes the airplane, the electrical charge doesn't penetrate the interior. Instead, it travels along the exterior, the conductive aluminum acting as a protective shield. The plane continues its journey, unaffected by the lightning's raw power. This visual demonstration should provide a clearer understanding of what happens when lightning strikes an airplane. It's a testament to the marvel of engineering that is an airplane, designed to withstand such extraordinary events. But as we mentioned before, this doesn't mean that an airplane is completely impervious to lightning. Stay tuned as we delve into the science behind a lightning strike and its potential impact on an airplane. Have you ever wondered what would happen if lightning struck a flying airplane? Well, let's start by understanding the raw power of a lightning strike. Lightning is a spectacular natural occurrence that is as beautiful as it is dangerous. It's a rapid discharge of electrical energy in the atmosphere, resulting in a bright flash and a loud thunderclap. The power of a single lightning bolt is immense, capable of lighting up a whole city block or even causing a forest fire. Now imagine this force colliding with an airplane cruising at 35,000 feet. The thought is daunting, isn't it? But here's a surprising fact. Lightning strikes on airplanes are not as uncommon as you might think. In fact, on average, every commercial airplane in the United States is struck by lightning more than once each year. But if that's the case, why aren't we hearing about plane crashes due to lightning strikes all the time? The answer lies in the design of the aircraft itself. Modern airplanes are marvels of engineering, designed to withstand not just the physical stresses of flight, but also extraordinary events like lightning strikes. The outer shell of an airplane is made of conductive materials such as aluminum, which allows the electrical charge from a lightning strike to travel along the exterior of the plane, leaving the interior untouched. So, does that mean that lightning can't damage an airplane? Well, not exactly. While the design of an airplane does provide a degree of protection, it's not an impervious shield. There are instances where lightning strikes have caused minor damage to aircraft, though these cases are rare and usually non-catastrophic. However, understanding the power of a lightning strike and how often they occur, it's crucial to delve deeper into the science behind it, the impact it has on an aircraft, and what happens in the aftermath. So, does that mean that lightning can't damage an airplane? Let's delve deeper. To understand what happens when lightning strikes an airplane, we first need to understand the science behind a lightning strike. Lightning, in essence, is a massive discharge of electricity. It's a natural phenomenon that's both fascinating and dangerous, but what causes it? The answer lies in the delicate dance of positive and negative charges. Picture a thundercloud. As it churns and roils, it creates an electric field. Within this field, the lighter positively charged particles rise to the top of the cloud, while heavier negatively charged particles sink to the bottom. This separation of charges creates a buildup of electrical energy. Now, let's bring an airplane into the picture. As the airplane flies through the sky, it disturbs the air around it, creating a pathway of less resistance for this electrical energy. The negatively charged particles at the bottom of the cloud see this pathway as an opportunity to connect with the positively charged ground. The result? A lightning bolt. But why does lightning prefer to strike an airplane? Well, the metallic body of an airplane is an excellent conductor of electricity. It's like a shiny, attractive beacon for those eager negative charges. And because an airplane is high in the sky, it's often closer to the thunderclouds than the ground, making it an alluring target. However, it's essential to remember that a lightning bolt is not just a single strike. It's a rapid series of strikes happening so fast that our eyes perceive it as one continuous flash. This is called a lightning stroke, and it's this intense burst of electricity that can be potentially dangerous to an airplane. But before we start worrying about the safety of air travel, it's crucial to understand that airplanes are designed to withstand lightning strikes. The principle is quite simple: to allow the electrical charge to move through the aircraft without causing significant damage, thus avoiding a catastrophic event. Now that we understand how lightning strikes, let's explore what happens when it hits an airplane. When lightning strikes an airplane, it's not quite the catastrophe you might imagine. You see, airplanes are designed with a lightning strike in mind. Engineers have carefully crafted these metal birds to weather the storm, quite literally. The outer shell of an airplane, often made from aluminum or composite materials, acts as a conductor for electricity. This is what we call a Faraday cage, named after the scientist Michael Faraday, who first observed the phenomenon in the mid-19th century. It's a principle that keeps those inside the cage safe from electrical charges. When a bolt of lightning hits an airplane, the electricity doesn't penetrate inside. Instead, it follows the path of least resistance, skirting around the exterior of the plane, from the nose to the tail. This happens faster than a blink of an eye. A blink and you'll miss it moment of electrical ballet. And what about the passengers and crew inside? Well, they're safe and sound. That's because the Faraday cage effect ensures the lightning's electrical charge stays on the outside. In fact, passengers might only see a flash of light and hear a loud noise. Of course, this doesn't mean the airplane is completely unaffected. The lightning can leave scorch marks or small punctures on the plane's outer skin, signs of its electrifying encounter. These are generally superficial though, and do not compromise the structural integrity of the aircraft. But despite these protections, a lightning strike is not without its challenges for an airplane. The electrical systems, for instance, can be vulnerable. While the plane's design shields passengers and crew from the lightning's charge, it doesn't necessarily offer the same protection to the sensitive electronic equipment on board. And this brings us to a pressing question. But what about the plane's electronic systems? Can they be affected by a lightning strike? Let's dive into that in the next scene. You might be wondering if a lightning strike can damage an airplane's electronic systems. Well, it's a fair question considering how much we rely on these systems for safe and efficient flight. Nowadays, modern airplanes are designed with numerous protections in place to prevent any substantial damage from lightning strikes. For instance, the outer shell of an airplane, also known as the fuselage, is primarily made of aluminum, a good conductor of electricity. This allows the electrical charge from a lightning strike to pass through the aircraft without affecting the interior or the vital systems. In addition to this, the sensitive electronic equipment and systems are often shielded with insulating materials to prevent any potential electrical interference. The airplane's design also ensures that any lightning-induced electrical surge is redirected away from vital systems and out through designated exit points like the tail, to minimize potential harm. However, despite these protections, lightning can sometimes cause minor issues. These might include temporary interference with navigation or communication systems, flickering cabin lights, or even minor external damage such as pits or burns on the airplane's surface. But it's important to note that these are typically minor inconveniences and rarely compromise the safety of the flight. Moreover, airlines and aviation authorities take lightning strikes very seriously. After a plane has been struck by lightning, it undergoes a thorough inspection to check for any potential damage. This includes examining the electronic systems to ensure everything is functioning as it should. Any minor issues found are promptly addressed before the airplane is allowed back in the air. So yes, while a lightning strike can indeed affect an airplane's systems, the impact is usually minimal and quickly resolved. And with the rigorous safety checks in place, you can rest assured that flying remains one of the safest modes of travel. So there you have it. While a lightning strike can sound terrifying, it's actually something that airplanes are well equipped to handle. Let's quickly recap what we've learned today. We dived into the sheer power of a lightning strike and the scientific principles behind it. We then explored how airplanes, despite being in the path of these potent forces, are well equipped to handle them. Their built-in defense mechanisms ensure the safety of everyone on board, even when lightning strikes. We also discussed the possible effects on the plane's systems, which are minimal. Next time you're on a plane during a thunderstorm, you can rest easy knowing that you're safe, even if lightning strikes. Before we wrap up, we have a small request. If you found this video enlightening and enjoyed learning about the power and science behind lightning strikes, please give it a thumbs up. It's a small gesture, but it helps us a lot. Also, don't hesitate to share this video with your friends who might find it interesting. We'd love to know your thoughts on this topic, so leave a comment below. And most importantly, don't forget to subscribe to the Wow Info YouTube channel for more fascinating facts and intriguing insights. Your support fuels our motivation to bring more enlightening content your way. Thanks for watching, and we'll see you